Hello friends, welcome you all. So in this video we will discuss the variants of Turing machine. Turing machine is modified in some way for different purposes. That all modifications, or you can say variants of Turing machine, we will discuss in this lecture. I have listed here some variations, and I will discuss one by one. And here you can see some non-power changing variations are there, and then some power changing variations are there. Now the question is, what do you mean by the power of Turing machine? The power of Turing machine we are considering here as the number of languages it can recognize or it can work on. If some machine, suppose some particular machine is working on can work on 5 languages, and some different machine can work on 10 languages, then the power of machine that which is working on 10 languages is higher than the machine working on 5 languages. So here power means we are considering the number of languages it can recognize or it can work on. That is the meaning of power of Turing machine here. Now here some non-power changing variations are mentioned. This means if we use multi-tape Turing machine, then they will not change the power. It may happen, the machine become faster, but the number of languages will always be same. So this is these all these variants or modifications we will discuss first, and then we will discuss no power changing variants. As you know friends, here till now the Turing machine we have discussed, it was having only one tape. So in case of multi-tape Turing machine, you can have more than one tape like this. Suppose this is one tape, then another tape will be there. So you can have any number of tapes with the Turing machine, and if number of tapes are more than one, then obviously for reading and writing on each tape, uh, had also be more than one. So for each tape and tape, one read write head would be there in Turing machine. So this is the meaning of multi-tape Turing machine. Here you can have more than one tape, and in comparison to single tape Turing machine, multi-tape Turing machine may be more faster. So now next is multi-track Turing machine. Here you have only one tape, but this tape is divided into multiple tracks like this. So suppose this is your one tape, and this tape is divided into multiple tracks like this, and all these tracks are finally divided into blocks. So this is like two-dimensional array here. So this particular multi-track Turing machine may have more than one track on single tape. And also, as with each tape, one read-write head is there, but in this particular variant, you may have more than one read-write head, one read-write head for each track. So this may also be there like this. So now third is non-deterministic Turing machine. Here we have for each combination of current state and present input, we can have more than one choices to as a next state, or more than one choices as next move, whether to move left or move to right. So here this is in normal deterministic Turing machine, we have all for one combination of input symbol and current state, we have exactly one next state. But in case of non-deterministic Turing machine, for one combination of current state and current input symbol, you can have multiple options. So this is non-deterministic Turing machine. Then two-way infinite tape. Two-way infinite tape. Till now in this particular playlist, the Turing machines we have discussed, all these machines had two-way infinite tape. That tape was infinite at both ends. And in this particular variant, one more variant you can add here, like you can have one way infinite tape. One way infinite tape, so this would be like one end of tape is fixed while other end is infinite. So this is also you can consider as one variant. So like two-way infinite tape Turing machine, you can have one-way infinite tape Turing machine. Or you can also call this variant as semi-infinite Turing machine. Semi-infinite tape Turing machine. So you can add one more variant here, like 10th variant, I can say. So semi-infinite tape Turing machine. So with this two-way infinite tape Turing machine, you can have semi-infinite tape Turing machine where that tape is at one end tape is fixed and at other end tape is infinite length. So this is also one variant of Turing machine. Now next is multi-dimensional Turing machine. So here also you have mm, same kind of tape as you have in multi-track Turing machine. So the tape is divided into multiple tracks. And as I told you, in case of multi-track Turing machine, you can have more than one read-write head, particularly one for each track. But in this multi-dimensional Turing machine, you have only one read-write head, which is working, which is reading or writing values on complete tape. So in this particular tape, as you can in normal Turing machine, you can move to left or right direction. So in this particular multi-dimensional Turing machine, you can have two more directions, like you can move to up direction or you can move to down direction. So there will be four possible directions for moving. So this is called as multi-dimensional Turing machine. Now next Turing machine is offline Turing machine. In offline Turing machine, friends, you have separate tape for input and you have two different tape for restoring intermediate result of any process and one separate tape for input symbols. So like you can in offline Turing machine, you will have two different tapes and that you can consider as one as input tape and other is working tape, or you can say work tape. So working tape, right? So you can read input from this tape. That means this tape would be only read only tape. And as this is working tape, so you can read and as well as write on this tape. So this is known as working tape and one separate tape for input is there. So this kind of machine is known as offline Turing machine. Now, if I consider this offline Turing machine, then obviously the next question may be there, like online Turing machine. What is online Turing machine? So you can consider this as one more variant of Turing machine. So online Turing machine. So here in offline Turing machine, you have a separate tape for input and working tape as separate tape. Now in online Turing machine, both tape would be combined or you can use only single tape for as input tape and working tape. So normally what we in Turing machine we have discussed till now in previous lectures, they all these machines were online Turing machine. So this is the difference between online and offline Turing machine. So you can consider all Turing machine which are working on single tape and storing the same and storing the input on the same tape. So you can consider all these Turing machine as online Turing machine. Now next variant is Turing machine with stay option. Turing machine with stay option. So as I told you, friends, in all Turing machine, when based on the current state and current input symbol, we change our state to new state, and we change this symbol to any other symbol, and also we move towards left direction or right direction. But in this particular machine, Turing machine with the stay option, you can have one more option, that to stay on that particular position. So you will not move, either you will not move to left direction or right direction. You will stay on the same position. So this kind of Turing machine, you can say Turing machine with stay option. Then one more variant of Turing machine is jumping Turing machine. Turing machine that we have discussed till now, we were reading one symbol at a time, and we were moving towards left or right by one position only. Like suppose your input is AB. So after reading this symbol, you were moving to that symbol, or after reading this symbol, you were moving to this symbol or this symbol. So here in jumping Turing machine, you can skip some symbols. So after reading this particular input, you can directly read this particular input, or you can directly read this particular input. You can skip some symbols in jumping Turing machine. So this kind of Turing machine you can consider as jumping Turing machine. So I hope, friend, these would be very much clear. Now, ninth variant, which is universal TM, Turing machine. So my friend, this is basically a digital computer, one kind of digital computer. And digital, as I told you earlier also, while we introduced the Turing machine, that Turing machine itself is a computer, and whatever you can do with a Turing machine, you can do with a computer. So that particular version of Turing machine, which is known as universal Turing machine, it itself is a digital computer. So I will not discuss it in this particular lecture. I will not discuss this in detail, but I will tell you, for now you can understand that this is exact version of digital computer. So this is known as universal Turing machine, and both these variants I have already discussed. So I hope all these non-power changing variants would be very much clear to all of you. And then I will discuss these power changing variants. Power changing variants. Now, in power changing variants, all these variants will change the power of Turing machine. That means Turing machine will start accepting less number of languages. So this all these variants will decrease the power of Turing machine. How? That we will see. Now, first variant is Turing machine with limited tape, or you can also call it Turing machine with fixed size tape. Fixed size tape. So when we are having Turing machine with fixed size tape or limited size tape, then it will work as finite automata. It will work as finite automata. And as you know, that finite automata can accept only regular languages. Accept only regular languages, while Turing machine can accept all kinds of languages. So it means if we are having limited size tape or a fixed size tape, then the power of Turing machine will be decreased. Now in this particular variant, Turing machine with input size tape, the difference, there is some difference. Limited size tape or input size tape, it these are totally different. Like if your input is 5 character long, then you are having tape to accommodate that particular input. If your input is 15 character long, then you are having sufficient tape to accommodate this input. So in this case, this Turing machine is known as Turing machine with input size tape, while Turing machine with limited size tape will have fixed size tape. That means it can accommodate only 10 symbols. Now, it is as it can accommodate only 10 symbols, so you can use 5 symbols or you can use 15 symbol, whatever you have there in your input, then you can use only 10 symbols at a time. You can store only 10 symbols at a time. So this is the difference between limited size tape or input size tape. So when the Turing machine is having input size tape, then it will work as linear bounded automata. Linear bounded automata. And linear bounded automata we have not covered in this particular playlist because this is used in type 1 languages. This is used in type 1 languages which are known as context sensitive languages or type 1 grammar, context sensitive grammar. So all context sensitive grammars are covered in separate subject which is known as NLP or natural language processing. So we can discuss this separately, but for now you can understand if Turing machine is having input size tape only always, then it will work as linear bounded automata, or you can note it down, linear bounded automata, linear bounded automata. And as you can see, Turing machine accept all languages generated from type 0 grammar, and LBA accept all languages generated from type 1 grammar. So that means Turing machine is more powerful, but LBA is less powerful. So in this particular variant also, the power of Turing machine is being decreased. Now I hope it is very, you can understand it. Now, the next variant is Turing machine with tape as stack. Turing machine with tape as stack. So when we are using the tape of Turing machine as a stack to store some symbols there, then it will work as PDA. So this is also power decreasing variant. Like you can see, PDA can accept all languages generated from type 2 grammars or context free grammars. So Turing machine can accept all languages from type 0 grammar, while this PDA can accept only languages generated from type 2 grammar. So again, the power of Turing machine is being decreased when we are having tape as stack, when we are using tape as stack here. So this is again power reducing variant. So when you are using Turing machine with tape as a stack, so it will work as PDA, push down automata. Now one fourth variant is power changing variant is Turing machine without writing capability. Turing machine without writing capability. So now you can see in all previous finite automata and PDA we have discussed in this playlist in very much detail. So in both these mathematical model, you were not able to write something, or you were not able to replace some input symbol. Now here, if we cannot write something on tape, then it means it would be read only tape. So in this case also, it will work as finite automata only. Finite automata only. So you can see, understand now again that Turing machine is accepting all languages generated from type 0 grammar, while finite automata will accept all languages generated from type 3 grammar or regular grammar. So again, the power of Turing machine is getting decreased. So all these variants that we have discussed, four variants we have discussed here, in all these variants, power was decreasing. Power re- power reducing variants. All these variants are power reducing variants. So I hope it would be very much clear to all of you. Now, if you have any doubt, you can always write to me in comments. I will definitely reply your comments. Thank you. Thank you so much.